welcome to C.M.P Lab. In this video, we begin our series on algebra. Now, we say that algebra, this is a branch of mathematics in which alphabets and numbers are manipulated using arithmetic operations to obtain results for a given problem. Alright, let's consider Let's consider 3 plus 3 plus 3 plus 3. Okay, this is equal to 12. Okay, and then by multiplication, we say that 4 times 3 is equal to 12. This is by repeated addition, and this is by multiplication. All right. So the same thing, a plus a plus a, okay, would be 3a. All right, and 3a will mean 3 times a. Okay, yeah. So 3a will mean a plus a plus a. Okay, or will be 3 times a. All right. Okay, the next thing we are going to consider is some examples of algebraic expression. All right, we have, say, 3y plus y, 3y plus y. This is an algebraic expression. We have 4x minus x equal to 2. This is an algebraic expression. Even if we have 5p, okay, 5p plus 3p, okay, minus 2x, okay, plus x. All right, this will still be an algebraic expression. All right, yes. Okay, where, for example, 3y is the coefficient and the y is the variable or unknown. Whenever a number is multiplied with an alphabet, okay, yes, the number is the coefficient and the alphabet is a variable. So like here, okay, this is the coefficient, this is the variable, this is the coefficient, this is the variable, 5 is the coefficient and p is the variable, 3 is the coefficient and p is the variable. All right, so now the next thing we are going to consider is the terms. Okay, 3y is a 10, y is a 10, 4x is a 10, x is a 10. Now, terms in algebra are always separated by, or terms in algebraic expression are separated by addition or subtraction. Okay, terms generally in mathematics are separated by addition or subtraction. So 3y is a 10, y is a 10. Okay, the next thing we are going to consider is rules of algebra. Now, I made this rule because students get confused whenever they are to obey arithmetic operations in algebraic expression. All right. Note one thing, that we can only add or subtract alphabets of the same type or kind. Okay, that is to say, we can only add, for example, a plus a is equal to 2a. Okay, and we can only add the numbers that carries the same alphabet. For example, 3a plus 3a, or 3a, right, plus 5a. Okay, and that's equal to 8a. All right, yes, we can only add or subtract alphabets of the same type, okay, or numbers that carries alphabet of the same type. For example, we can subtract, say, a minus a, okay, that's 0. Or we can subtract, say, 3y minus y, that is 2y, okay. So we can subtract or add alphabets of the same type. Okay, the next is the multiplication. All right, the multiplication. Now, a times a is not 2a. Okay, students make this mistake. All right, a times a is not 2a, right? Rather, a, this is not, okay, this is not 2a. Rather, a times a is a square. Okay, whenever you see a square on top of a number, whenever you see a square on a number or an alphabet, you know that expression is associated with multiplication. All right, okay. Now, the next thing I want us to understand in algebra is that even though we can't add or subtract numbers that carries the same alphabet or alphabet of the same kinds, we can multiply them. Okay, what I mean, we say that a plus a is possible. All right, got 2a. Okay, now a plus b is not possible. Okay, yeah, a plus b is not possible. All right, we cannot say a plus b. Okay, but we can multiply a times b. We cannot add a plus b, or neither can we subtract a plus b. Neither can we add, for instance, 4a times 3b. Okay, no, sorry, 4a rather, I mean, plus 3b or minus 3b. No, this is not possible. All right, but we can multiply a times b, which will give us ab. Okay, we can as well multiply 4a times 3b, which will give us 12ab. Okay, we cannot add or subtract different alphabets, okay, but we can multiply them. Okay, the next thing I want us to consider is when an algebraic term reduces to 1. When an algebraic term reduces to 1, we don't show it. Okay, for example, a means 1a, but we don't show that. Okay, we simply write a. All right, or 1a, okay, is a. Okay, for instance, if we have 3a minus 2a, this is simply equal to 1a. Okay, but we don't show this one, we don't show this coefficient of 1, we put it as a. Okay, so now if you have y plus y, okay, solving this by factorization, this means solving this by factorization, this will mean 1 plus 1 bracket y, which that's equal to 2, and we open the bracket, that's 2 times y, and that's equal to 2y. All right, yes. So we don't show the coefficient of 1. When an algebraic term reduces to the coefficient of 1, we don't show it.